Alright, okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Selamat tengah hari. Okay, semoga semuanya berada dalam keadaan yang baik, dalam keadaan yang sihat. Subhanallah, hari ini dah Allahu Akbar. Kita dah berapa hari dah berpuasa kan hari ini. Subhanallah. Okay, 16 kan? Dah 16 Ramadan dah hari ni. Dan semalam dah 15, dah masuk semalam dah 16. Okay. Dan semoga semuanya berada dalam keadaan yang sangat-sangat baik, okay, dan makin-makin energetik, okay, untuk meneruskan misi kita ni. Kan misi wahai bangsa postgraduate. Alright, bangsa postgraduate-ku yang ku sayangi, yang ku cintai kan. Of course, okay, kita nak tamatkan journey ini dengan bahagianya, dengan jayanya. Sebab apa? Sebab life after PhD sedang menanti kita. Okay, dan itulah masa untuk kita contribute kembali, okay, apa jua kepakaran yang telah kita perolehi semasa di dalam PhD journey kita. Subhanallah. Alright, okay. So apa khabar semuanya? Alright, so kita tengok siapa yang ada bersama-sama dengan kita, okay, untuk live pada hari ini, dan saya sangat-sangat bersyukur. Subhanallah. Okay, memang kita mula sharp. Sebab saya tengok tadi team dah play around 12.28 dan sharp 12.30 saya dah masuk untuk kita start the program. Allahu Akbar. Memang sangat terbaik team. Okay. Alright, so kita ada siapa di Facebook buat masa sekarang ni? Kita ada Hatia Ismail, okay, Hafizah Raja Syahari, Dania Irfan, Tasnim Ismail, Waalaikumsalam. Siapakah tetamu pada hari ini? Nanti kita akan panggil. Bukan calang-calang orangnya. Full prof Cepat panggil kawan-kawan. Alright, so boleh invite rakan-rakan anda, okay, untuk sama-sama mendengar perkongsian daripada full prof. Alright, yang akan berkongsi tentang tajuknya apa? Kita akan cakap lah sebentar lagi. Alright, okay, so kita ada Sheila Prasad, kita ada Mazna Ibrahim, kita ada Ju'azul Hisham. Saya dah boleh sebut lah nama dengan betul ni. Laju pun dah boleh cakap dah, tak tersasul lah. Okay, Zaifa Ismail, Wanina. Wanina, come on. Wanina, tag kawan-kawan, kita bidang yang sama. Okay, civil engineering lagi you. Faz Jumali, on the way ke USM. Tag kawan-kawan. Panggil semua bangsa postgraduate dekat dekat bilik PG USM kan. Ni kita ada prof bersama-sama dengan kita pada pagi ni. Pada tengah hari ni untuk berkongsi. Untuk berkongsi tentang kepakaran. Kepakaran beliau, okay, pada slot as expert pada kali ini. Yes, Waalaikumsalam. Okay, Cik Puan Irma Syardina. Waalaikumsalam, Nur Hasina, Cik Razi. Okay, come on, tag. Teruskan tag rakan-rakan anda untuk kita terus menaikkan, okay, bilangan mata, okay, bilangan viewers, okay, yang menonton slot as expert kita pada tengah hari ini, insyaAllah. Alright, of course, hidup masih ceria. Okay, sebab kita tak nak memberatkan you all kan. So kita je santai, okay, discuss a new knowledge kan. A new knowledge. Bila di dalam background yang berbeza, okay, kita mendengar sesuatu perkara yang baru. So of course, kita tak nak membebankan you all, kita akan secara santai untuk memberi kefahaman awal lah, just a general and also a basic knowledge, okay, untuk kita tahu apakah sebenarnya skop kajian, okay, yang perlu kita tahu. Dan of course, okay, bila saya berbincang dengan prof, okay, antara soalan-soalan yang akan kita tanyakan, saya sangat-sangat tertarik. Of course, semua soalan sangat-sangat menarik. Yang terakhir, seriously, future tu, okay, sangat-sangat penting, okay, untuk kita tahu apakah yang perlu dilakukan, okay, di dalam bidang ini. InsyaAllah, membuka mata wahai rakan-rakan engineer, okay. Dan juga of course, okay, yang di dalam bidang yang sama. Dan siapa kata kalau bidang yang lain tak diperlukan? No. Okay, ada juga kesinambungan, the continuity yang kita boleh guna, alright, yang kita boleh adapt, okay, di dalam kajian kita. InsyaAllah. Boleh, Zulina Abdullah nak panggil geng teknik, panggil je. Yes, Ju'azul Hisham, pagi yang luar biasa. Kita setiap pagi kan? Itu yang tersasul tadi. Yes, setuju. Gitu. Okay. Yes, betul. Okay, skop kajian yang berbeza. Okay, menarik untuk kita kongsikan ilmu-ilmu yang daripada background yang berbeza. Alright. Okay, so please, okay, naikkan mata. Come on. Penting ni. Okay, penting bilangan viewers yang nak menonton ni. Okay, so tolong tag rakan-rakan anda. Okay, so sementara tag tu kan, so apa kata, okay, boleh tulis di ruangan komen, alright, di manakah anda melanjutkan pengajian anda, okay, dan juga di dalam bidang apa. Okay, so kalau saya seperti biasa kan, I love. Saya USM, okay, PhD in Structural Engineering, University Science Malaysia. Rakan-rakan kita yang ada kat sini mungkin boleh share, okay, you all punya background, okay, dan you punya university, okay, supaya expert yang bersama dengan kita pada hari ini tahu you all ni daripada mana. Okay, come on, silakan. Okay, Zurina Ulwa, I love UPM, PhD in Bahasa Melayu. Subhanallah, amazing. Okay, dan kita ada Siti Najihah, UTHM, PhD Science. Sains ni ada kaitan ni. So boleh dengar betul Okay, PhD in Project minggu lepas. TS2 banyak yang kita dapat kan. Alright, and then kita ada Yuniza, PhD in ELS. ELS tu apa Mungkin boleh ni sikit. Okay, and then Sanggis Ramalingam, UKM, PhD in TESOL. Mana kaum saya ni? Faz Jumali. I love. USM, PhD Civil Engineering. So Prof boleh cari dia nanti Prof. Okay, USM PhD ni, Civil Engineering ni. Boleh cari nanti dekat bilik postgrad. Nak kena reveal tak postgrad mana tu? Alright, okay. Alright, so boleh terus komen. Okay, anda daripada universiti mana dan dalam bidang apa. So kalau nampak mata saya ke bawah ni, saya tengah baca komen lah. Kan, okay, and then boleh terus tag. Boleh terus tag rakan-rakan anda. Okay, untuk bersama-sama dengan kita pada sesi tengah hari ini. UMP PhD Fluid Flow Numerical Analysis. PhD Fluid Flow ni pun part juga sebenarnya kan, daripada engineering juga. Okay, and then kita ada Chemical Engineering, UITM. Ni UITM Shah Alam ni, subhanallah. Okay. Tak apalah kan, Prof nak kenal-kenal ni, no problem. Okay, so sebelum kita panggil expert, right, untuk bersama-sama dengan kita pada tengah hari ini dan untuk kita membincangkan apakah topik kita pada hari ini, izinkan saya untuk memperkenalkan, of course lah, tak kenal maka tak cinta kan. So izinkan saya untuk memperkenalkan siapakah expert kita pada hari ini. Okay, tadi tengok poster je kan. Yang ni kali ni kita nak tengok, nak dengar background beliau. Okay, dan juga sebentar lagi kita boleh dengar a serious discussion about the topic yang akan kita bincangkan sebentar lagi. Alright, of course. Nak ceria kena vibe dengan bahagia. Subhanallah, bila sebut tentang bahagia, honestly speaking, saya sangat-sangat berterima kasih kepada expert kita. Kan beliau, saya merasai kenikmatan Viva tersebut. Apa yang terjadi, insyaAllah saya akan kongsikan nanti. Alright, so siapakah panel kita pada hari ini? Panel, expert kita. Expert kita pada hari ini adalah Profesor, Insinyur IR Dr. Choon Kok Kiong. Is currently a professor in structural engineering. Kan saya cakap tadi kan, I love USM, PhD in structural engineering. Kami dari background yang samalah, of course. Iaitu beliau adalah full prof, structural engineering daripada School of Civil Engineering, University Science Malaysia. University Science Malaysia. So bila kita sebut engineering ini, kampus dia bukan di Indo ya. Jangan tersilap, kampus ni bukan di Indo, kampus ni adalah di Nibong Tebal. Engineering punya kampus adalah di Nibong Tebal dan uniknya kampus engineering ataupun kampus kejuruteraan Nibong Tebal ini adalah lokasinya 5 minit kita boleh masuk negeri baru. Memang dekat sangat. Dia berjiran dengan Parit Buntar. Parit Buntar masuk Perak kan. So lagak dekat Perak gitu. Sebab 5 minit dah masuk negeri lain lah. Okay, Dr. Chong ataupun Prof Chong obtain, alright, his from the University of Tokyo, Japan in 1994. Okay, and he teaches subjects on strengths of materials. So bila sebut strength of materials, of course saya sangat yakin orang yang daripada background mechanical engineering, you sangat-sangat familiar, right, dengan strength of materials, and you should be here, to learn our discussion for today. Seriously. Alright, and then theory of the structures, design of RC structures, and also the undergrad level and stability of structures, and advanced structural mechanics, at the postgraduate level lah. So pendek kata Prof ajar undergraduate juga ajar postgraduate level, iaitu master by coursework. Okay. Right, his major research, include computational analysis, of shell and spatial structures, di mana itulah topik yang akan kita bincangkan sebentar lagi. And then about the structural dynamics, structural dynamic ni apart from my research juga, alright. And then the structural stability, of course there is the continuity, alright, between structural dynamics, the structural stability, and also the computational mechanics. Semua mengimbau kenangan masuk USM ni pun tebal. Silakan. Right, so he also collaborates with industry on research study related to the precast concrete structures, right, large span steel structures, vibration measurement, tension fabric structures, real scale measurement of structural performance, as well as use of computational simulation in structural prototype development. Yes, of course. Right, of course. So sangat-sangat penting. So bila kita daripada background engineering ni, ini adalah soalan biasa. Soalan biasa yang akan ditanya dan akan dilihat, which is bila kita buat experimental, alright, of course, tak kisah you buat experimental, you buat simulation dan sebagainya, of course kita kena ada validation, the validation process ataupun the verification purpose. So of course kalau kita tengok background Prof ni, memang akan melibatkan juga sekali dengan computational simulation. Sangat-sangat penting. So dia ada the continuity dan saling berhubung kait. And also he is a professional engineer, kan, sebab tadi ada title IR, registered with the Board of Engineers Malaysia since 2016. Subhanallah, right? Amazing sangat. So semua, so ini adalah antara, alright, background expert kita pada hari ini. So sebelum kita panggil masuk expert kita, so are you ready guys? So kita nak tengok berapa orang yang dah ready untuk bersama-sama dengan kita pada tengah hari ini. Sebab yang ready boleh komen ready, we are ready. To be with Prof Chong. Come on. We are ready. Come on, ready. Yes. Ready. Good. Kita nak energy you yang sangat-sangat luar biasa. Come on. Yes, seriously. Semua ni ada. Semua title ada. Prof ada, IR ada, doktor ada, subhanallah. Come on, lagi. Yes, ready. Alright, so tanpa membuang masa lagi, saya sangat yakin Prof sangat-sangat banyaklah yang nak dikongsikan bersama-sama dengan kita pada hari ini. So team dipersilakan untuk menjemput masuk kita punya expert pada tengah hari ini. Silakan. Dah nampak nama. Subhanallah, thank you so much Prof. Welcome. How are you? Good afternoon.
Afternoon, Shikin. Afternoon. Thank you for having me today. Okay. Can you hear me? Can you hear me well? Yes.
Thank you so. Yes, very clear.
Okay.
Yes. Yeah. Your voice is very clear. Right. So thank you so much. To be with all of us today. Alright. In order to share your knowledge, your expertise. About the shell and spatial structures. Alright, efficient form active load carrying structures. Okay, so for your informations, okay, our audience today is coming from the postgraduate students, and of course they are from a different field, different
Okay.
background. So we can see just now there are some from, yes, from the TESOL background, and then
Yeah.
chemical engineering, right, mechanical engineering, and of course we also have from the civil engineering. Okay, and your students too, Prof, together with us. Okay, so
Mhm.
before we start, okay, before we go further, okay, our discussions, maybe you can share with all of us, okay, about your publications, all right, along this journey, and also the postgraduate students. So how many postgraduate students that you already have until right now?
Okay. Okay.
Silakan, Prof.
Thank you. Thank you very much. First of all, it's again nice to be able to meet you in this way, and then also good afternoon to all who are currently online. Um, First of all, let me, I think, maybe just share, I think, what Dr. Shikin asking just now, I think. Now, in terms of students, I think currently I am supervising, I think, two PhD students. I think currently one is about to submit, and then the other one is maybe another year will complete. And I also have one master students by research and another three by mixed mode. And since I joined USM starting from year 2000, I have graduated, I think, about 8 or 9 PhD students as a main supervisor, and 2 or 3 PhD students as a co-supervisor. Okay. Now, in terms of publication, so I of course, my area is computational shell and spatial structures. So I normally publish together with the students and also sometimes from the industries on topic which I hope I will share later with all of you, things related to shell and spatial structures. So of course we also but now because of the COVID we do not do that. So of course we also publish in conference as a way of sharing what we know with the audience. And sometimes we give talk and then to seminars or at the conferences. So that is a bit about what I am doing now at the School of Civil Engineering. Okay, Shikin. Yeah.
Alright, okay. Thank you so much, Prof. Okay,
Yeah.
so untuk makluman semua sebenarnya Prof Chu ni juga adalah mantan timbalan dekan postgraduate students. So Prof memang ada banyak sangat pengalaman, okay, untuk deal dengan postgraduate student ni. So insyaAllah, alright, at the end of these sessions, so kita akan minta okay, pandangan Prof dan juga nasihat daripada Prof untuk dikongsikan dengan rakan-rakan sekalian, okay, bagaimana, okay, as you as a postgraduate students, okay, apakah antara yang you perlu lakukan, insyaAllah, okay, at the end of this session. Okay, thank you so much, Prof. And bila
Okay.
Prof mention tadi, dah graduatekan berapa orang students as a main, also as a co, okay, so honestly speaking, thank you so much, Prof. So I'm the
Yeah.
ones, your students,
Correct.
saya takkan lupa our mock viva, okay, because from your questions during our mock viva is really helped me, okay, during our real viva, because some of the questions that you asked me during our mock viva is really asking by the examiners. Oh, it's quite surprising me, but it's also I'm very thankful to God. Right, thank you so much, Prof. All right, so our topic today is about the shell and spatial structures. Okay, efficient from active load carrying structures. All right, so Prof, maybe, okay, for the first questions, you can explain to all of us in a simple way, okay, what is the meaning of shell and spatial structures, efficient from active load carrying structures. All right, silakan Prof.
Okay. Thank you, Shikin. So I see there are a lot of people from different disciplines. So let me try to explain. So the topic itself is talking about load carrying capacity of structures. So we know, I think structures are built, constructed to functions. I think it can be hotel, it can be buildings, it can be houses. So they serve as a functions related to what the buildings is for. And as civil engineers, I think engineering, we are more concerned about the load, yeah, the load that the structures is supposed to carry. I think the weight that we put on the structures. So we need to know, I think, how much load it can carry so that we can design them properly. So this is about load carrying capacity. And the other thing will be what we talk about form active. I think now later I will share with the help of the team over there some examples of shell and spatial structures. So shell and spatial structures, the name implies is a kind of structures which is where the shape of the structures plays a very important role in helping the structures to carry load. Okay. And efficient, the term efficient in engineering, we always try to economize, I think, our structure. So efficiency here in terms of how much load it can carry. For example, if it can carry 10 kilonewton, yeah, per meter square, and then in comparison with how much materials we have to use. Okay. So the ratio of how much load it can carry over how much material we need to use to construct the structures is a kind of measurement of efficiency. So the higher the ratio, then we can say that the structures in terms of material usage is more efficient. Now for shell and spatial structures, I think can we share the slide that can we share the first set of the slide? Is it possible so that I can explain using some examples?
Sure, Prof. Alright, okay. Team, minta bantuan kita share the slide. Alright, thank you so much. Alright, please, Prof.
Yes, you can see I prepare some slides just to help to explain what I intend to share today. Now, efficiency, as I mentioned, you can see is ratio of load carrying capacity over cell weight. Okay, this is in terms of how much efficiency in terms of material that we put in, how much load it can carry, as I explained just now. And then form active, it means that the geometry itself. After that, when we go to the next few slides, we can see the shape, the geometry, the shape, and sometimes in engineering, we call that configurations. For this category of structures, shell and spatial structures, they play an active role, which means the shape is important. Can we go to the next slide? So I'm going to explain what is shell and spatial structures in order to help you to understand what are we talking about. So for your information, shell and spatial structure in engineering, this is the way we group them. This is under one particular group of structures. So after that, you can see what we call the space frame structures and what we call the membrane structures and tensegrity structures and cable dome structures. And sometimes we use combinations of cable and membrane in the structures. So can we go to the next few slides of the example? So shell and spatial structures, I think maybe some of you have can roughly relate from the name. Okay, so shell, if you look at shell, we can relate to shell, seashell, or eggshell. So shell is a type of structures where the shape is curved in shape. So like what we normally see in animal living in the sea, the seashell, I think the shell. So example of this kind of structures are, this is a very historical building, our stadium Nagara. Okay, as you can see, this is one of the characteristics of the shape. It is curved in shape, and normally it covers very large area. It covers very large area without any intermediate support in between. And on the right-hand side, you can also see the historical building, the Stadium Merdeka. So what I would like you to see is the roof over the grandstand there, which is can span quite long span, yeah, in order to cover the spectator sheet. So this is this is made of concrete. So it has the characteristics also. It is curved and it is relatively thin, okay, and is able to span a very large space without any intermediate support. So these are our first example that I would like to share. So the characteristics is in the shape and it normally covers a very large space. Next slide, please. So another one, which is the Stadium Negara, Stadium Merdeka, is quite a historical building, and a more recent one is will be our Sepang International Circuit. Okay. So this is an aerial view. Aerial view, right hand side shows the aerial view of the structures. So this is another category of structures that we call shell and spatial structures, and this is specifically constructed using materials that we call membrane, very flexible, thin kind of construction materials. Next one. So this is another view of the structure. So you can see here, I think the structures, I think at the background of the motorcycle, which is racing in the race course there. So this is a structures where it can span a relatively large space. I think without any intermediate support, you have only supports at the end of the structures, and it is made using a membrane, a very thin construction materials. So next one. So to give you an example, so to bring you to the idea of shell and spatial structures, so this is another view of that, and on the right hand side, you can see a row of that structures which is used to cover a very large space, I think, without any intermediate support. Next one. Okay, so this is showing, I think, just to show to you the supporting structures on the left hand side. On the right hand side, this is I think you can't see there are people on above the roof there, which is fixing the fabrics or the membrane, the white color one, to the frame. Next one. So those are membrane structures, I think, which is used in our international Sepang circuit. The next one will be our Bukit Jalil National Stadium. So again, now you can get the feeling these structures typically cover very large space, I think, suitable to be used in stadiums and other applications where you need a very large unobstructed view. Okay. So this is the left hand side is Bukit Jalil National Stadium. This is a cable dome structures. So you can see in the center there's an opening and there's a ring. There's a ring surrounding that opening. So that is a tension ring. And then it is being pulled. It's being pulled to another ring, which is we can't see from here, along the edge of the stadium, that we call the compression ring. So this tension and compressions, they act together and then forming a structures. And on top of that, we cover with membrane, just forming a very large stadium. On the right-hand side, this is on the same Bukit Jalil National Sport Complex area. This is our National Aquatic Center. So this is actually a roof also made of membrane, and this is the interior part, and the roof is being suspended. You can't see the pylon outside there, so you can see the four flower type structures there. These are actually connected to cable, and the cable connected to very high pylon, and the pylon is supporting the whole membrane roof. So next one, please. So another one, familiar one, is KLIA structure. So again, you can see that similar to other typical example that I show, they are all covering very large space without any column in between, minimum column in between, and they have the features of being curved, yeah, the shape. Next one. So another example, this is in Sarawak, back in East Malaysia. Also, we have this kind of structure. So I just want to show various example. And the one Guthrie Pavilion, I think, but now I think it is has the design has changed. This is when it was first completed. So on the right hand side, you see cable, and in the background there, used together with the membrane, and they are supporting the roof. And this roof is actually an air cushion. When it was first constructed, there was like a big pillow where we have a pressurized air forming a roof and suspended from the pylon, which is connected to a series of cable. So next one. Now on the left hand side, this is also another type of shell and spatial structures where you can see really the members are arranging in spatial way. So the term spatial meaning that they are arranged in the 3D ways, forming a structures. So the one on the left hand side is actually a project of my students where we study these kind of structures, and we actually constructed one in USM engineering campus. So from the one on the left hand side, you can see all the members connected together, forming what we call tensegrity, tension and compressions, helping each other, forming the structures with rigidity. And the one on the right hand side is a typical, I think, structures that we can see when we need a very large space. And you can see that this is a space frame structures. This is in Fukuoka, Japan, a stadium. This is a station building. So we have a kind of tree-like. So this is also another innovations that has been proposed in this area. So we follow the tree. We follow the tree, the way tree are supporting its own leaves. So trees are one example of spatial structures where the branches are extending in all directions. So this has been studied and copied in engineering and come up with this kind of what we call the branching structures, so that we can carry the load distributed nicely. So a few more examples, then I will end the first part of it. Next one, please. So this is very close to Penang. This is a spice, I think, spice roof in Penang. I think the one on the left hand side is during daytime. The right hand side is during night time. So this is a single layer space frame, and another characteristics, and one more time characteristic you can see is covering very large space, and then and it has a typical curvature. Next one. So this is anyone who have been to Changi Airport and has a opportunity to visit. This is a very famous, I think, structures and engineering achievement. This is Jewel Changi Airport. So this is also a single layer space frame structures, and normally if you look at the structures, I think we tend to have the center point higher, but this one, because I think the architects or the planner want to create a waterfall, so the center point become lower. Okay, so this is a bit different from the normal space frame structure that we see. So the center point become lower. So this is another example of space frame shell and spatial structures. Next one. Okay, so that is Shikin hopefully give some idea on shell and spatial structures. So the characteristics that we can associate with this kind of structures is the member arrangement in 3D. Okay, so the members is arranged in a 3D manner for efficient distribution of load, and it has curvature. It has curvature. So I hope I have to explain a little bit on what I intend to share with all of you as the first part. Is it okay?
Alright, okay. Thank you so much who are not in this field. So at least you have an early figures, alright, to know what it is actually right about the shell and spatial structures. So we can
Yeah.
see a lot of very unique, right, very unique buildings, very unique structures actually. Okay, and I think when I see the aesthetics, right? Aesthetics values that we can see from that
Yeah.
structures. So we can make a conclusion that maybe before this, the architect and also the engineer maybe kita kata apa, ada perselisihan faham lah, right? Architect will come with bombastic bombastic design, alright, but maybe when it go to the engineer maybe cannot doing alright exactly what the architect want, but from this shell and spatial structures, alright, maybe the dreams will be come true. So mana geng architect? Alright, so mana geng architect? So adakah anda gembira pada hari ini sebab minggu lepas kita ada berbincang tentang satu topik. Okay, berkaitan bila mana sometimes engineer ni bila dapat satu drawing daripada arkitek, maybe kita tak boleh nak buat because of some conditions dan sebagainya. But now from the shell and spatial structures, semua benda itu tidak lagi menjadi satu, kita kata apa, satu mustahil tetapi boleh menjadi kenyataan. Best tak bestnya, memang best sangat lah. Okay, shell and spatial structures. Mana arkitek? So adakah anda bersetuju pada hari ini? Come on, comment. Alright, okay. So thank you so much, Prof. Alright, for the early explanations about the shell and spatial structures to all of us. Alright. So from the slides that you showed just now, right? So the shell and structures, including space frame structures, membrane structures, tensegrity structures, cable dome structures, hybrid cable, and also the membrane structures. So is it all of these elements you are covering in your research right now, or maybe what is your involvement right now in this area?
Yeah, I think basically all those different example of shell and spatial structure, whether space frame, membrane, use of cable and membrane. So those are the I think the type of shell and spatial structures that I am involving in. Okay, so the only thing that the type of shell structures that I haven't I think directly involved is concrete shell. Concrete shell. So other than that, I think what you have seen just now, I basically get involved in those kind of shell and spatial structures, either in terms of trying to see how they behave. I think this is one of the things that we need to know as engineers. So, and then is the current method able to help us to understand as much as possible? So, what are the methods of simulations, analysis, modeling that we need to do? So I basically carry out those kind of research, and sometimes I also look at, I think, can we find new alternative way, new shapes using those materials. Okay. So yes, basically I get involved in all these things except concrete shell.
Alright, okay, Prof. Alright, so rakan-rakan sekalian, right. So bila kita tengok gambar sebentar tadi, alright, a lot of pictures, okay, that Prof sharing with all of us, okay, dan salah satunya adalah kita boleh tengok salah satu shell structures ni kita boleh tengok dekat Spice Penang. So lepas ni siapa yang datang Penang, jangan nak serbu. Kadang-kadang dia orang serbu nasi kandar je, Prof. So lepas ni boleh pergi Spice, okay, untuk tengok sendiri. Right, dengan mata you all, pergi waktu malam, sangat cantik, seriously. Waktu malam sangat cantik kan, dengan lampunya. Okay, untuk kita lihat keunikan, the example of the shell and spatial structures. Okay. Alright, next, Prof. So, when we talk about the load carrying structures, so last week we are talking about the earthquake loading that acting on the structures, right? But today we're talking about the load carrying structures, right? So what makes shell and spatial structures efficiently, right, as a load carrying structures?
Yes, I think the first thing is because of the shape. I think so. I think many of us are familiar if you I think look at the a flat piece of bar, and then you try to stand on that bar, and you will get, I think, quite large deflections because of the shape. But if you put a curved shape, if you curve it up, and then you try to stand on that bar again, so you will see that it deflects less. I think, of course, the support must be properly properly held. So one of the characteristics, Shikin, and to all, why shell and spatial structures are efficient load-carrying structures is because of the shape, the curvature. So the curvature helps to transfer the load, not through bending, yeah, not through bending, but through axial actions, which is compression or tensions. So for engineering, if we can carry the loads by axial action rather than bending, so we can fully utilize the materials sections, which means that we can have smaller sections, lighter lighter members. So the first thing is the curvature, the shape. So the second thing is to Shikin and the rest of the audience here is because it is spatial. I think so. The word spatial here meaning that the members, the arrangement of the members is really in 3D. So meaning that the load, when we want to transfer load, we must the load are transferred through materials that we use. So if let we can distribute the members, which is distributes our materials in the 3D way, and then the load can be more efficiently distributed in all directions rather than we restrict them in certain directions. So this is another reason why. I think the first is because of the curvature. The second is because we arrange the members in 3D way. So when we do analysis of spatial structures, we have to consider that as 3D. So we cannot, I think in most cases, we cannot break it down into what we call a 2D structures and to analyze because it really needs all the members together to carry the loads. So those are the reason I think Shikin and the rest are why shell and spatial structures are efficient structural system.
Right. Okay. Thank you so much, Prof. Right. So we have one questions right from the
Okay.
audience, which is the questions is what is the advantage by using this kind of the structure?
Okay. Now the advantage is first, I think if you want to have efficient usage of materials, because it is efficient, meaning that to serve the same functions, I mean to carry the same amount of load, you need less materials. So one of the advantage is you can have less material, and then when you use less material for the structures, you get less overall cell weight. When you have less overall cell weight, then your foundations also will become less bulky. So you save also in terms of the constructions of foundations. So I would say, I think the first thing is because the way it carry loads, it can be efficient, so it become more lightweight, and it helps in your foundations, and also it helps in during the constructions if you need machinery for lifting, because if you are lightweight, then the machinery used can also be of lesser capacity. So that is what I can say to the questions. What is the advantage? Okay.
Alright. Okay. Thank you so much, Prof. Saya kalau orang tanya saya tahu satu je yang kita nampak, which is in terms of the spacings and space structures, which is we can eliminate the number of the columns that used for
Yeah.
the traditional building, right? And of course, when you talk about the less materials, right? And then automatically it will less the overall surface that acting on the structures. So automatically the foundations, right? The
Yes.
foundation also can less bulky. Okay, so it will affect it. Okay, for the whole structures starting. Wow, kita punya seriously, this is a new knowledge, alright, and hope, okay, for those yang tengah menonton sekarang ni, for those yang tengah menonton sekarang ni, so saya rasa you all dah mula nampak, okay, what is the difference, okay, between all the types of the space, shell and spatial structures, okay, that using for each types of the structures that we have. Okay, dan bila nanti you datang ke Penang, you tengok spice, you tahu oh ini adalah kategori yang mana. And then tadi beberapa contoh yang Prof tunjuk tadi dekat airport dan sebagainya, oh itu that kind of another types of the structures. Alright, so there is another questions, Prof, okay, from Mayamin Yohanis. Okay, what software do engineers commonly use to design the structure? Are there new software being at interest for the structure designing?
Okay, I think for software, I think as long as you have a software that can do, I think, analysis of 3D structures, where most of the software are able to do now, you can analyze them. Of course, for space frame, I think many software are able to do that work. I think for say space frame, because basically it is a beam or a truss member that we arrange in 3D. And for another type of structure, which is membrane structures, then you need a little bit of specialized software. I think normally company using specialized software, because membrane structures need a kind of process that we call form finding, because membrane structures is flexible, and then you need to pull it, and depending on how much you pull it and what is the supporting point, the resulting shape that you're going to get will be different. So you need a specialized software to do that part, which is a form finding part. Then after that, the stress analysis, I think if you have a software that can do shell analysis, I think membrane analysis, then you can use that software. But normally for these kind of structures, people use specialized software to be in one integral part, right? From form finding, go to structure analysis, and finally you have fabrics, membrane structures. If you look at the example just now, you can see that they are made of pieces which are sew together. We connect them together. So it's like when we are making clothes, we cannot use one whole piece of cloth and then make the clothes. We have to cut them into pieces and then connect them together using sewing machine. So fabric structures has that characteristics where you need to stitch them together. So what are the pattern you're going to stitch them, and when you apply tension later on, they are going to give you the shape that you want. So that is another analysis which is needed. So for that reason, specialized software is needed. That is the patterning. We call it the patterning analysis for membrane structures. So other than that, I think cable structures, any software that are able to consider cable, and you can do that. Only thing is, I think shell and spatial structures are normally very, deflections tend to be high. So you need to know nonlinear analysis. So that software must be capable of carrying out this nonlinear analysis, considering that the deflections, deformations are high. Okay. So software, I think any software that you can, I think, carry out 3D analysis, you can do, but for membrane structures, you need specialized one, and you need to do nonlinear analysis. Okay. So I hope that I do not give specific name of the structure software, but just what are the capability of the software required. Is that okay? Yeah.
Alright, okay. Thank you so much, Prof. Alright. So tadi kita dengar, okay, you alright, dan cantiknya shell and alright, sorry. I think my line. Okay. So next question, Prof. So is there any challenges, alright, in the constructions of the shell and spatial structures? Okay, di sebalik kecantikan bangunan tu, Prof.
Yes. For that, I think boleh kita share balik. I think saya continue tadi. So I put up a few points, the slide tadi. Boleh.
Alright, okay. Team boleh share slide balik tak? Alright, okay. Silakan,
Next one,
Prof.
please. Next one. So as you mentioned, I think we agree that any structural system cannot be good only good, and then there is no weaknesses. I think of course there are some of the special considerations that we need to pay attention to. So the first thing is I think the shape is important. So accurate determination of form of structures, okay, during analysis, I think, and also during constructions is important. So when you do in constructions, I think it have to pay attention to controlling the shape of the structures. So this will require some extra expertise, I think, in terms of surveying, I think controlling, and also use of appropriate construction technique. So the first thing is the shape is important to take care of during analysis and design, and also during constructions. Then secondly, disebabkan I think structures, shell and spatial structures, because it carry loads through axial actions, meaning that tension compression. So we know that, I think, for engineering students, we know that when you have compressions, then always there is this risk of buckling. So careful checking of buckling is very important. So we have to do, I think, detailed analysis whenever there are parts of the structures in compressions, because shell and spatial structures are carrying loads through axial action, meaning that compressions or tensions. So we have to careful checking of buckling. If not, then the whole structures will become unstable. Okay. After that, I think the other part would be careful planning of construction method. And one of the things that shell and spatial structures is very important for them to maintain that shape is the support, yeah, our foundations. So the support must be carefully constructed and then make sure that they are rigid so that the shape of shell and spatial structures can be maintained. So careful planning of construction method is needed. So next one, I share with you, I think, what we meant by construction method. Can you go to the next slide? So you can see this is spice. I think this is spice during construction. So when we look at spice now, it is it is one space frame supported at both ends. So, but before the all the pieces are put together, so you need to support them. So so in this particular case of spice, the contractors use a lot of scaffolding to provide first the working platform as well as to provide the support to get the shape that they want. So you can see from the left hand side, the top, this is at the beginning of the constructions, and as it progress, okay, as it progress towards the front part, you need all these supporting temporary structures. And this has to be carefully planned, okay, and has to be carefully, I think, monitor as well. Where do you put the supporting point to get the shape that you want? Okay. So on the right hand side, this is a close up detail where for one of the things that we need to pay attention to is the construction method, temporary supports during constructions. Okay. So another thing is I think that you need to take note of, especially for space frame structures like this, is how do we take down the temporary support. So you must do it carefully. So there must a careful analysis. You cannot take down all the points, I think, in any sequence that we want. So you have to take down the supporting point when all the members are already in place. You are ready to remove the temporary structures. So we have to do careful analysis to help us to determine which one we can release first, next one, which one, and finally the whole structures can support itself. Okay. So these are among the challenges, I think, that we need to pay attention to. Okay. Okay. So those are the challenges I think we need to pay attention to. Okay. So this one I will describe later. Okay, for research studies. Okay.
Right. Okay. Thank you so much,
Okay.
Prof.
Okay.
So we are now knowing right about the challenges, okay, in the construction of shell and spatial structures, and of course, when we see the unique structures, the unique buildings, I'm always thinking about what you are mentioned just now about the support, okay, how they connect each other, and of course, still, okay, how it can be formed in a shape that we want. So it's when we talk about there are some the challenges, okay, that we had been faced, right,
Correct.
by the designers. Right. Okay. So, Prof, the next questions is, what is your focus research, right, in this space, in this shell and spatial structures, and of course, okay, when we talk about the shell and spatial structures, we want to know more, okay, about the future, okay, of the shell and spatial structures. Please, Prof.
Okay. I think for research study, so can we go to the slide? So I just list down what the researchers are doing, and then I try to relate to my focus of research. Okay. Can we go to the slide just now? Okay, so this here I think for the audience and to share the all these are research study in shell and spatial structures. So there are people looking at analysis. There are people looking at constructions. I think so for analysis because of the issue of buckling. So people are coming up with a better analysis method, which is I think faster and more efficient and can be catered for structures with very large number of members. So estimation of buckling, local buckling and overall buckling, this is one of the, I think, focus area of research. And form finding, as I mentioned, there are certain structures, you need to find the form first, depending on how you arrange the members and depending on if you apply pretension force and also depending on how you support. So better method for form finding. Okay. Then lightweight materials. I think there are new advancement in materials that we can see. So there are people working on use of lightweight materials in the constructions of shell and spatial structures. Now, one of the things that we need to pay attention to shell and spatial structures is vibrations, because shell and spatial structures are lightweight. So earthquake is not a major deciding factor, but rather wind. Wind. Wind is an important one because of the lightweightness of the shell and spatial structures. Especially you have a very large span and the roof is very flat, so tendency to get very large, I think, suction or undesirable wind pressures is one of the things that people have to pay attention to. So better prediction of vibration characteristics. So this is where people can use CFD for computation analysis, and also people are also doing wind tunnel tests on these things. So new form of shell and spatial structures. I think we find forms. I think as you can see, and also Shikin mentions aesthetic part of it. So people are looking at a new form, how we can copy from the nature, and how we can copy from the nature. Some of the shapes in nature are very beautiful, and it looks like it's suitable to be used. So we can also, I think, try to copy that. But is it any issue when we copy to a scale that we see in engineering structures? So these are another focus area, new form of shell and spatial structures. Free form is not cylinder, is not spherical, is not hyperbolic, but free form. Organic form, I think you learn from nature. So better prediction of acoustic effect. So this is related to when it is used as a hall. So when it's used as a hall because of curvature, so how we can tune the curvature here and there to have a better acoustic, especially when we want to use shell and spatial structures for music hall or where acoustic is important. So this is also another area people are working on. Application of idea from nature. This is related to can we copy the system? And also, I think people are looking from applications from arts like origami art. Can we I think get idea from this folding paper art in order to apply it to engineering. Okay, for origami is a kind of paper folding, so we can copy that. People already copy that for structures which can change shape, like the piece of paper, you fold it, then you can change shape. If you pull it a bit, then the shape changes. Okay, so these are among the research study, and I'm focusing on form finding. My area of research is I'm looking at form finding and also applications of idea from nature. So I look at shape of leaves and maybe shapes of how we can see any advantage of that thing, and also new form of shell and spatial structures, better prediction of vibration characteristics, and also get idea from origami in order to come up with structures that can change shape that we call a folding shape. And so these are the research study and the one that I focus on. Now back to the question of future, I think because shell and spatial structures is efficient, so it is a choice that we can consider for sustainable as a sustainable construction. So, and of course, there are some challenges that we need to overcome. So, construction method. So maybe we need to look into a better way of simulating. I think the construction sequence right from the beginning until the end of the constructions, and also until you remove the support. So the future will be, I think, how to overcome those challenges, so to make these structures, I think, a more viable solutions. Okay? And of course, materials. I think materials that we want to use. So we have to look at making full use of the advantage of advancement in materials, so that we can have a structure which is even more efficient. Okay? And other things will be, I think, shell and spatial structures in terms of load carrying capacity, they're efficient, but there are some other problems that we have to overcome, like the acoustic effect. So these are other things that we need to find a method in optimizing the shape, considering not only the strength aspect but also considering also the performance aspect. So we must have a method that can do these things, so that it can serve the purpose to be efficient structures, but not totally, I think, concentrate only on structural aspect but also other aspect, because the structures need to serve certain functions. Yeah? If your structures can be very good in carrying loads, but the acoustic is terrible, so people will tend to do not want to adopt that system. And other methods is maybe automations in constructions. I'm talking about concrete shell. Now, one of the reasons concrete shells has become not so, people are not doing concrete shell anymore, is because of the form work that we need to spend a lot of time in order to get the form that we want. So maybe nowadays, but we know that concrete shell has a very good load carrying capacity. We can look into, I think, a 3D printing method, where you can print the shell in a certain parts and then bring them to the site to connect them together, and then to make sure they function as much as possible by paying attention to the connection as a whole shell structures. So these are among the things that I think is the future that we should future research study, or that we should look at. Okay. So
All right.
that's what I would like to share about these two aspects. Yeah. Okay.
All right. Okay, Prof. So when you talk about the applications of idea from nature, so now I know
Yeah.
and I can relate it with the when we are going to the Bukit Bendera, I
Yeah.
think on 2018,
18.
19, something like
Yeah.
that. So there is some structures. It's exactly okay, idea from nature. Now I understand. Okay, when you
Uh,
share about this, okay, and we can relate it. So rakan-rakan sekalian, right? So if you are interested, kan, so when you are coming to Penang, okay, instead of you are going to the Spice, you can go to Bukit Bendera too. Okay, so dekat situ nanti berbalik kepada discussion last week Dr. Izana dengan Dr. Okay, yang bersama dengan Dr. Izana masa tu, they are talking about the forest therapy. So bila you pergi kat Bukit Bendera tu, you boleh tengok the examples of the structures what our Prof share with us just now. And also, it is in the forest. So it's quite a very beautiful scenery, right? So boleh datang beramai-ramai nanti. Okay, so Prof, there is one questions, right, from Mr. Faizal Hazri. Okay, apa komen Prof, right, berkenaan bila mana sekarang ni banyak binaan bangunan yang mudah runtuh dan juga bocor. Adakah teknologi luar tidak sesuai digunakan di Malaysia yang beriklim tropika, dan juga kini kita pun sedia maklum kan selalunya berlaku ribut petir. Bila tadi Prof mention about the wind loading. So maybe Prof boleh komen?
Yes, I think this is a very good question. So now, I think bila berlaku kegagalan or something happen to the structures, so there are maybe a few factors that we look at. First is the design properly consider all the possible load effect. So kalau I think we design for wind, I think do we design for the worst case of the wind, the wind force, that wind pressure that might happen. Okay. So if we overlook certain aspect like this during I think our design, then normally when normal wind comes we don't have problem. But suddenly there's one day where the wind is terrible, and then it produce pressure which is, I think we didn't consider that, so that might lead to failure. Okay, so this is during design stage. I think the second thing is, of course, as engineer, we know when you do design, then you must construct according to what you design. So, which means that the proper site monitoring to make sure that what you construct is according to what has been designed, especially in terms of connection detail and also the quality of materials that we use. Okay. So these are the things that I think we need to look at. Of course, sometimes due to, I think, maybe some development in weather pattern. So kita sometimes kita tak pernah tengok angin sekuat macam ni, sekencang macam ni, tiba-tiba angin kencang macam ni. So those are the things that is for the researchers to look at. It's time to try to maybe relook into the standard that we have. Is the wind speed that we use, is it suitable? I think considering latest incidents that happen, development. Okay. So these are among the few factors that I think can contribute to failure. Okay. So of course, I think certain design principle are all this. Design principle is the same all over the world. I think you have to design for strength, and then the only thing that approach that we adopt is different. But when it talks about local conditions, so those are the things that we need to pay attention to, especially wind conditions. I think so. Maybe we need to we can use standard from other countries as a reference, and then to see how much it suit to us, and then need to do our own research here, data gathering, to see whether we should change some of the consideration which is specific, which is site specific. Okay. Then another thing will be, I think, estimations of when we nowadays we use computer analysis, so we must know how to interpret the result from the computer analysis, computer software. So to have a strong understanding of how the structure behaves, so the load first acting on this go to where, how the load is being transferred. So that sense of engineering basic is important, I think, to in order to detect any sign of possible defects or possible, I think, insufficiency in design right from the beginning. Okay. So that strong engineering sense of how the structure carry loads. So ada lagi satu lagi ada apa? Is that answering all the questions?
Yes, yes, Prof. Of course, right. So it is actually back to the basic, right, in design any buildings, any structures, which is in
Yeah.
terms of the loading, in terms of the analysis, right, and of course by following the standards, okay, in order to ensure what is exactly the parameters that we need to use, okay, during the designing process. Okay, so Prof, maybe last question, questions about the maintenance. Okay, so Prof, bagaimana pula dengan penyelenggaraan struktur untuk shell and spatial structures? Bagaimana pihak engineer bertindak dalam menyediakan struktur yang selamat dan juga efisien?
Yes, yes. I think this is a very good, very important question. So structures, bila kita design for that, there's a certain lifespan that we design for, and then also to achieve that lifespan too, there must be some durability aspect that we have to pay attention. So in terms of maintenance, of course, kalau we are using steel, we are using steel structures, so the maintenance will be have to have regular checking on these. I think possible sign of corrosions. I think which has to be rectify earlier. So maintenance for corrosion checking. And of course, I think bila kita guna steel, of course, right from the beginning, the corrosion protection must be done properly. So maintenance is important, yeah, to make sure that the structure can behave, I think, can carry loads without any loss in strength that that can happen. And other things will be, I think, if you are using membrane. So if you are using membrane, so tension is important for membrane structures. So there must be a way that you can monitor the tension in membrane or tension in cable to do regular checking, and at the same time, you must get ready some device that you can do tensioning again if necessary, if structures using tension. Okay. So these are the things that we have to pay attention to. And of course, if we are using concrete, so concrete, then we know that I think the concrete must have be able to protect the steel inside. So we have to make sure that sufficient concrete cover are provided so that when the concrete and steel they can work nicely as a structural part. So any leakage that might happen, so we need to check regularly, and then also the water flow. I think the other thing is when shell and spatial structure have very large roof surface, we have to make sure that the water flow nicely. Tak ada tempat yang air boleh bertakung, and then you tend to have problem. Okay, the water must flow very nicely. Okay. So these are also things that important to take care of to make sure that the structure is durable. I think it can serve the intended service life. Okay, so this so that is I think my thought on this maintenance part. Maintenance, I think, I want to say is important in any structures. I think so that should be a culture maintenance.
Right. All right. Okay. Thank you so much, Prof. Right, for your time with all of us. Okay, for today's sharing about the shell and spatial structures. All right. Efficient form, active load carrying structures. All right. So for your information, Prof, tomorrow will be next another sessions. All right, with another host and also the experts, which is we have host technologist Dr. Nudaya Ahmad. With the expert is technologist Muhammad Khairi Sulaiman from JKR Malaysia. And they are going to discuss about the BIM dari sudut pandang industri. So please, alright, don't forget to join the session tomorrow. Okay, so boleh ajak rakan-rakan, okay, ramai-ramai untuk bersama-sama dengan slot bagi keesokan harinya, okay, berkaitan dengan BIM. Okay, dan juga Prof, sebelum kita end of these sessions, right, maybe Prof sebagai mantan kepada Timbalan Dekan postgraduate, so is there any advice from you who have a lot of experience deal with the postgraduate students? Okay, what is your advice to all of us, to all the postgraduate students that who are hearing your sharing right now? Please, Prof.
Okay. So let me try to share. So the first and foremost, I think you must have a very, I think, clear schedule of what you want to do. Okay, and then you, based on that schedule, you have certain what we call milestone, milestone roughly, and you work towards that milestone. And think finally your last milestone is submission of your thesis. So along the way, it's very important that you keep regular contact with your supervisor. Okay, supervisor, I think, because he is the one who is going to, he or she is going to want to guide you, your supervisor or your co-supervisor. Okay, so of course, I think there are also cases where I think student facing problem, difficult to contact supervisor, supervisor tak jawab email, supervisor tak jawab WhatsApp, supervisor tak jawab surat, supervisor tak jawab ini, tak jawab itu. Okay, so I think that is of course another issue. So keep close contact with your supervisor, and then also have a group of people that you can refer to. Okay, because sometimes I think bila kita buat sesuatu, kita perlu bantuan, ini software got stuck sini, who can help me? So have your own friends or other staff in the same school who has that expertise that you can refer to. So you have to you have to seek help whenever you need to. Okay. So of course, the other thing is, I think, right from the beginning, it is very important to be clear about, I think, what you want to achieve. I think, which is along the way, our research direction might shift here and there, but the overall aim must be clear, so that I think kita ada satu aim which is that we work on. Okay, so be clear about your research plan. Okay. So other than that, because nowadays I think with this internet availability, to look for information is very fast. I think very fast, but sometimes we need to discuss some aspect. Bila kita baca, we are not sure whether this is applicable to my case or not. So this is when you need to refer to your supervisor or your co-supervisor. Okay. So those are among things that I think is important. Having a clear research plan, which is what you want to achieve. Then at the same time, I think have close communication with your supervisor, so that he can advise you when you are lost, to give you directions. I want to let you know that I think by the end, when you finish thesis, you are expert. I think you know better. You know the detail more than the supervisor. Okay, but the supervisor, our role is to guide you in the direction, in the direction. Okay, and as Shikin mentioned also, I think because we examine thesis of other students, we sit in thesis examination meeting, so there are some expectation that the panel has, okay, about your thesis. So those things must be properly addressed to make sure that you don't have problems when you submit your thesis and eventually when you sit for Viva. Okay. So those are maybe some of the things that I can share with the students. I think, yeah. So those are. If you have any other things that you like to ask me, Ms. Shikin, maybe can share my email you want to ask. Okay. So because there are problems of different nature, but okay. But have your research plan. I think have your milestone, and then I think have close communication with your supervisor. Okay. If your supervisor susah mau cari, then you have to cari your timbalan dekan, and then this minta advice. I think how to do. Maybe the timbalan dekan can give some advice. So that is my advice. Okay.
Alright, okay. Thank you so much, Prof. Wah,
Okay.
ini memang kalau kita orang punya term kan, memang siapa tak sedar lagi ni tak tahu nak cakap. So memang very straight to the point. Okay, which is we just need to follow what Prof mentioned just now. Okay, in order to ensure that you are in a right track. Okay, and you know what are you going to do and what are you going to face it right during this journey. Alright, okay, so thank you so much, Prof, right, for your times
Thank you.
during these
Thank you
sessions.
for
And untuk makluman semua, boleh saya share email Prof dekat sini sama-sama dengan
yeah.
rakan-rakan sekalian, which is
Okay.
email Prof adalah cekkc@usm.my. Okay, so
So
saya letak dekat komen cekkc@usm.my. Alright, so
yeah.
anyone yang ada further questions, okay, in order untuk bertanya lanjut kepada Prof, boleh contact this email. Okay, and once again, thank you so much, Prof, for your time, and of course, thank you so much for your helping during my PhD journey. Seriously, I'm very, very happy. I'm very,
My
very
pleasure.
grateful for my PhD journey. Thank you so much, Prof. See you again next time, Prof.
Thank you all. Thank you, Shikin, and thank you to all. I think anyone, please, just feel free to email me. Okay, I will try to answer. Okay, so have a nice day to all. Thank you very much again for having me. So I hope this topic has been this topic sharing has give you some idea about what shell and spatial structure is all about. Okay, thank you all. Thank you.
Alright, thank you so much, Prof. Okay, Alhamdulillah, Subhanallah. Okay, sedar tak sedar kan? Almost, sebenarnya ada satu lagi soalan tau, tapi sebab kita pun bersuntukkan masa. Okay, but hope if kita ada lagi sharing pada masa yang akan datang, so kita akan spot that questions. Okay, so based on the advice daripada Prof Chung sebentar tadi, Profesor IR Dr. Chung Kok Kiong, iaitu sangat-sangat penting you kena clear in whatever you are doing, kan. So itulah antara yang selalu ditekankan oleh doktor, okay, kepada kita semua. Kita kena clear, kena ada milestone yang jelas, apa yang you nak. So inilah yang kita kata kadang-kadang big why tak pernah nampak, tolonglah clearkan, make sure you are very, very clear, okay, dengan apa yang kita nak buat, apa yang kita nak, apa yang kita harapkan, okay, sepanjang journey ini. Okay, dan saya suka point yang ketiga, kena kerap contact SV. Kena kerap contact SV. Jangan nak main biola Jangan main biola bila ada SV yang tak balas message ke, tak balas email ke. Jangan nak main biola. Okay, yang penting adalah kita keep email, kita keep contact, okay, kita punya SV. Untuk pastikan kita ini tak tergantung, kita kata apa, kita nampak hala tuju kita tak terawang-awang. Okay, dan kita tahu apa yang perlu kita lakukan. So sangat-sangat penting, seriously. Okay, contact SV ni memang, ya Allah, saya sokong sangat. Sangat penting, jangan sesekali lari daripada SV. Walaupun kita rasa kita tak ada progress, kita tak tahu apa kita nak buat, walaupun kita rasa kita bastard tu nanti kita nak kena marah, just hadap saja. Okay, percayalah, keluar saja daripada bilik SV, kita akan nampak apa sebenarnya yang kita kena buat. Kan. So dia ada masa kita nampak, ada masa tak nampak, itu normal as a student. So we as a student, seperti mana yang Dr. Salman cakap hari tu kan, kita sebagai student tak salah untuk kita bertanya. Just tanya saja soalan tu. Walaupun kadang-kadang kita rasa itu adalah soalan yang mungkin diconsider sebagai stupid question, but as long as you are students, okay, kita boleh tanya sahaja kan. Alright, and then of course untuk kita kena ada group. Ingat PhD journey ini bukanlah a lonely planet, bukanlah a lonely journey. Of course we have a circle. Okay, sometimes when we are stuck at this part, so siapa yang kita kena jumpa? Okay, dan tadi Prof Chong ada cakap, sometimes maybe there are some experts yang tahu tentang benda perkara yang kita tak nampak pada masa tu. Okay, dan bila kita refer, insyaAllah kita akan dapat jawapan. Right, and keep discuss, right, dengan SV dan juga co-SV to ensure that kita punya study, kita punya research itu berada dalam track yang betul. Okay, and of course seperti mana yang saya cakap di awal start kan sesi kita pada sesi pada tengah hari ini, okay, di mana saya cakap seriously saya mengucapkan jutaan terima kasih. Kalau sebelum ni saya hanya bercerita tentang supervisor saya hanya berbicara tentang co-SV saya. So inilah co-supervisor saya, iaitu Profesor IR Dr. Chong Kok Kiong yang banyak membantu saya sepanjang journey PhD saya. Okay, and memang fundamental beliau sangat-sangat strong, sangat-sangat kuat, dan saya banyak belajar in order untuk kuatkan writing, okay, thesis kita. Alright, and of course semasa sepanjang sesi mock viva kami, okay, boleh dikatakan, saya rasa boleh dikatakan semualah, okay, expected questions daripada examiners itu semasa sesi mock kami ditanya exactly semasa dalam bilik viva. So that's why saya cakap saya suka sangat-sangat viva saya. Okay, sebab banyak perkara yang saya belajar semasa sesi viva saya, dan of course journey PhD ini banyak mengajar diri kita untuk berhadapan, okay, selepas life after PhD. Okay, ingat semasa hari jadi doktor kan, pada 18 Mac yang lalu kita ada sesi di mana doktor ada mention bahawa kita membawa karakter kita di dalam bilik viva itu adalah karakter yang akan kita bawa keluar, okay, selepas kita dah habis PhD. So sangat-sangat penting you kena bawa karakter yang betul ke dalam bilik viva. Dan honestly speaking, terima kasih banyak-banyak kepada supervisor dan juga co-supervisor saya yang expert yang bersama dengan kita pada hari ini, okay, yang telah memberikan, yang telah membina satu karakter yang betul, okay, kepada diri saya untuk masuk ke dalam bilik viva dengan satu karakter yang betul. Subhanallah. Okay. Alright, and of course, yang last sekali, ingat kita adalah expert kepada thesis kita, kepada kajian kita. Sebab apa? Sebab kita yang buat research tu, okay, dan SV and also the co-SV guide kita, bantu kita, tunjuk kita ke jalan yang betul, okay, untuk pastikan kita berada dalam track yang betul. Tetapi ingatlah, okay, from A to Z, you are writing your thesis and you yang tahu apakah contents, okay, yang sepatutnya ada di dalam thesis tersebut, kerana you adalah expert kajian tersebut. Subhanallah. Okay, dan apakah kelebihan anda berbanding dengan orang yang tak menonton hari ini? Okay, di mana anda telah belajar beberapa jenis kan, kategori ataupun jenis types of the structures under shell, and nampak dah boleh kategori, oh ini adalah membrane structures, ini adalah tensegrity structure. So banyak. Okay, and once again saya ucapkan juga kepada Profesor IR Dr. Chong Kok Kiong kerana memberi peluang kepada saya untuk join the mobility exchange students, okay, yang kita kata apa, memberi peluang kepada saya untuk pergi ke Jepun pada tahun 2017. Subhanallah, satu pengalaman yang sangat-sangat luar biasa. Okay, dan di situ kita dapat kembangkan ilmu pengetahuan kita tentang kajian kita bila mana kita berbincang, kita berdiskusi dengan profesor dari luar negara berkaitan dengan tajuk tesis kita. Subhanallah, face to face. Alhamdulillah, syukur. Okay, so itu saja. Alright, untuk sesi Ask Expert kita pada hari ini. Okay, so jangan lupa seperti mana yang saya cakapkan sebentar tadi, esok kita akan bersama dengan teknologis Dr. Nurhidayah Ahmad, okay, bersama dengan expert teknologis Muhammad Khairi Sulaiman, iaitu daripada JKT Malaysia. Tadi tengok kat ruangan komen banyak yang dah kenal. Okay, dan esok kita akan berbicara tentang BIM dari sudut pandang industri. Okay, itu sahaja daripada saya. Sekian, wabillahi taufiq hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih semua. Allah jaga semua. Bye-bye.
Okay.